everybody, today we'll discuss about randomized complete block design analysis, especially in different locations using RStudio. RCBD design is used to make sure treatments are compared under similar circumstances. For example, imagine that the natural fertility of a field varies from one to other. So if you are conducting a field experiment to compare different types of fertilizer, then clearly the natural fertility could affect your suggestion or recommendation or conclusion. For example, if you used a CRD design, that means a completely randomized design, there is some chances that the one fertilizer treatment may end up with more replicate on the more fertile part of the field. As a result, you might conclude that this fertilizer treatment was better than the other fertilizer types. So in such situation, you said that the effect of the fertilizer was confounded with the natural fertility of the land. That means the natural soil is interfering with the conclusion about the fertilizer effects. As a result, if there is known or suspected field variability, you want to block your field. To remove any advantage as well as disadvantage one treatment. This means you should not be favor or discriminate any treatment that might have because of its position in the field. So in RCBD, a set of experimental treatments are grouped or blocked in a way that it minimizes the variability within each block, and you then have other blocks, and each contains a complete set of treatment. As a result, you reduce variability within the replicate or within the replication or within the group. Meanwhile, you will actually increase variability between the replicates, which can be estimated to separate source of variation. So the removal of this source within the replicate variation will help us to reduce the experimental error, and also in similar fashion it improves the ability of the experiment to detect the smaller treatment differences. So the greater the variability among the block, that means, or it will tell you that the more efficient the design are. So but in some cases, if you are not detect a large difference between the blocks, so then you could use a completely randomized design or CRD, which would actually be more efficient. So this is because a CRD has more degree of freedom for error and thus have a similar F value to detect significant difference among the treatments. So these are the suggestions that I give to you. And in this design, that means in the randomized complete block design, the field is divided into replicates or blocks. That means usually we say a replication. And each block in this divide into number of plots or units. That means equal to the number of treatment. And within each block, the treatment are assigned at random, so that different treatment is applied to each experimental unit. So for this tutorial, the following packages are required: car, reshape, reshape 2, and agricole, emins, and lastly the NME4. So I suggest you to incorporate all this into your studio. Then after, I already imported my data. My data name is R, and let's see some part of the head, the top 6 of my data structure. Here is the replication, the treatment, here is the pH, here is the location, and here is the YD, that means the yield, and here is HI harvest index, this is response variable. Let's see my structure. Sometimes if our structure is not factor, so we must convert into factor. For instance, here is replication, treatment, and location are characterized as integer, character, and integer respectively, but we have to convert from this character or from this integer, from this structure to factor by typing this into our R. So type this one and submit to our studio, and in similar fashion do this. So by this way it will convert. By this way you can convert the number integer character into a factor. Let's check again. Yes, here is the replication and treatment, and here is the location is converted into a factor. Before proceeding to analysis, here is the model for the randomized complete block design over location. Here is the response variable that are going to be analyzed. Here is the location plus treatment, and again treatment plus location, and finally the replication against replication times location plus the error term. So we minimize error, we never get rid error from our system. So this is the model. So immediately come to analysis, and you can assign any name that you want. Here is the linear model. Here is PH standards for the response variable, maybe YD, maybe HI, maybe it's different for you. And as explained by treatment plus location, and again treatment against treatment times location plus location times replication, then finally data is equals to R. So submit this to our studio. Then let's see the ANOVA of this model. Yes, here is you are expecting location, treatment, and as well as location times replication. So the treatment degree of freedom is 6, location is 2. We have 2 locations, so n-1 is 1, and treatment times location is 6. That means 6 times 1 is 6, and location times replication is 4. And here also the residual is 24. And here the treatment is significantly affected, the plant height, and the location is highly significantly affected the plant height. And again also here is the treatment as well as the location also highly affected the plant height. So we must go for post-hoc analysis. So to do that, it's very simple and easy. You can give any name that you want. Here is I just give ls here, and the method of the post-hoc test that I'm going to use is lsd.test. But the previous one, that means lsd test, then here is the module Q, the treatment degree of freedom is 24, and here is 94.26 and alpha 0.01 if you use a p adjustment binary. So automatically will give you a false result. So we never use this this method. So instead you have to use the function is lsd.test. Then you have to indicate the module. So y is equals to q what we generated here. Then the treatment is trtu. So you can type this one and submit to your studio. So you can also you'll get some statistics from this. To do that, you have to get the least significance difference, then the statistics. Statistics means the mean, the error, the t-value, the p-value, the error mean square value, and also CV. So to get that, type this and submit it. And finally, you can also create the groups. That means grouping on the basis of mean, especially giving of lettering. So if you want to do that, so you can attach from this value the groups. So type this and submit. Let's see the group. Yes, here is the group. So the highest plant date observed from 15, and is followed by 3, and the list was obtained from treatments that contain 6 value. So by this way you can get the mean group. Alternatively, you can also get some statistics value like CV, error mean square, degree of freedom, t value, so and even also LCD value. So this way you can get further detail of your static. So this is all about the randomized complete block design over multiple location or over location. So if you have any question regarding to my tutorial, you can address me through my email wabijratasfound at gmail.com. Thank you for watching.